Hi class, today we're going to talk about the areas between curve. So in chapter 5, we defined and calculated the area of regions that lie underneath the graphs of functions. So area under the curve. Today we have two functions and we want to find the area in between. Now, as you can see that we can divide the regions into strips of equal width, and then we approximate the area. And then we take the limit of the Riemann sum. So it's exactly like chapter 5. And this time we have two functions. So the area between the curves would be the integral of f of x minus g of x. So this is the upper bound and g of x is the lower bound. Okay. All right, let's just go straight into example 1. So example 1, we need to find the area of the region bounded above the y equals to e to x power and y equals to x power. It helps if you know the graph. So you can see right there, we have the curve, the two curves, and we need to find the area of the shaded region. So you can see that we have the boundary already. So the area is straightforward. It's gonna go from 0 to 1. F of x, in this case, the upper bound would be e to the x power, and then the lower bound would be x. And then you just integrate it, right? So it's really easy, straightforward. E to the x powers minus x squared over 2, and we want to evaluate from 0 to 1. Okay, and then from there, you can just calculate, and then you can use a calculator. So what I have is e minus 1.5. All right, I'm just going to give you the exact answer. Like I said, you can use a calculator and figure out e. All right, so that's very easy. Now let's just go into example 2. Notice that example 1, I give you the size, x equals 0 and x equals 1. For example 2, we don't know it. We only know the two curves, which is y equals x squared and y equals 2x minus x squared. All right, so like I said, it helps if you know the graph. Okay, by the way, you should know the graph of y of x squared. So I'm just going to draw that graph right there. Okay, the other one, you can use your graphing calculator here, or if you know how to graph, that would be great, by hand. It's going to be this one. Right? So you can see that this one right here is the y equals x squared. This one is a negative x squared, right? So this one is y equals 2x minus x squared. Okay. The reason I want to do this is I want to figure out which one is the upper bound and which one is the lower bound. So which one is the top and which one is the bottom. All right. So as you can see, the top one is this one, right? The other one is the bottom one. Anyway, we need to know the interval. We need to know what to integrate from, right? So how do we do that? This is what point of intersection. So how do I find a point of intersections? I just set them equal to each other. So if I put the two equals to each other, x squared equals 2x minus x squared. Okay, and then of course you need to know how to solve it. Okay, so I can just add them over, subtract 2x equal to 0. You factor it, right? So you can see that x equal to 0 and x equals to 1. Okay, so we know that this point right here is going to be 0, 0. This point right here is going to be 1, 1. Okay, and then from there, we integrate. So from there, I'm going to integrate. Okay. So what do I have? I have 2x minus x squared minus x squared dx. Okay. So as you can see, this is the upper and this is the lower, right? So this is the top, this is the bottom. Okay, so from there, you should know what to do. So I have 2x minus 2x squared. I can definitely take the 2 out. 0 to 1. X minus x squared dx. So what we have is 2x squared over 2 minus x cubed over 3. And then we want to evaluate from 0 to 1. So I have 2. We plug it in, so it's 1/2 minus 1/3. So the answer is 1/3. And that's the area.